Alright, hi year 12, this is Mr. Lim here again, and this is our video on acidic and basic nature of salts. So let's get going. Alright, so this is what we're going to learn. Alright, so let's get started. Some ionic salts can be acidic, basic, or neutral. Okay, so this is the salt that is produced. These things can be acidic, basic, or neutral. Their nature depends on their component ions, okay, so the ions that make them up. So when asked to identify if a substance is acidic, basic, or neutral for the ionic salt, you must identify both components. So you say, okay, well, this is the cation, this is the anion. Then you state both of their natures, whether one is neutral and one is acidic, or one is acidic and the other one is neutral, right? Then show via a hydrolysis reaction if they are acidic or basic, right? And then ideally you would memorize this table. Okay, so here we have a table that you should go memorize, right? You can, I think I'm having this in the booklet so you don't have to copy it down, but that's the idea. You should memorize this booklet, right? This table. So generally, now this is generally, so it's not in every situation, and this will really annoy me if you're just going to use this rule all the time, okay? So generally, components of salts formed from strong acids or bases are neutral. Okay, so if it's from a strong acid or base, it's neutral, generally, right? They completely ionize and do not reform into their reactants. Again, generally, components of salts formed from weak acids or bases are basic or acidic, depending on how you, what you got. So a weak acid, the salt from a weak acid is basic, right? Or the salt from a weak base is acidic. But, this is a generalization and useful for unknown acids and bases. So if they say, oh, here is a weak acid, then, and then they don't tell you its formula, just say HX or something, then you should know that, okay, well then the X minus is going to be a weak base, right? But for known ions, you should memorize the table, okay? And there's a reason for that, because not every salt from a weak acid or base or from a strong acid or base follow these rules, which is why you should memorize the table. So let's go through some examples. Potassium chloride. So what you should first do is identify the two ions, potassium and chloride. Then you should identify that the potassium is neutral, and, well, so is the chloride. And if they're both neutral, then the salt equals neutral. Okay, nice and easy. Okay, magnesium ethanoate. So we go through the two things, magnesium and ethanoate. Okay, so we should know that, well, using the table, magnesium is neutral and ethanoate is basic. You should show that by showing the reaction CH3COO minus with water, the hydrolysis reaction, right? Will form CH3COOH plus OH minus. It's therefore the salt is basic because it produces some OH minus ions in solution. All right, then ammonium nitrate, well then you should know that it forms from two ions, the ammonium and the nitrate. The ammonium is acidic, the nitrate is basic. No, not basic, neutral. All right, the NH4 plus, you show that it's acidic by showing what it will form when it reacts with water, which is the hydronium ion. So therefore the salt is acidic. Now, what happens if you get a mixture of a acidic and a basic ions? Then it's going to depend on the Ka and the Kb of those two particular component ions. But that's unlikely to occur unless you really do get the Ka and Kb of those two ions. Right? The sulfuric acid and the phosphoric acid series, you should memorize in terms of their nature. Okay, so sulfuric acid, H2SO4, that's obvious, that's an acid. Hydrogen sulfate ion is also acidic, and the sulfate ion is basic. All right, so again, when we talk about the generalization that the salt from a strong acid is neutral, this is the example where it's not true. Okay, so the sulfuric acid, the two salts, well, that you could possibly form from it, hydrogen sulfate and sulfate, they have acidic and basic natures, right? So do not just use the generalization. You've got to memorize the table, and you've got to try and remember when to apply the generalization, only when you've got unknown, acids and bases. Okay, so the phosphoric acid, that's acidic. The dihydrogen phosphate, when it's lost one hydrogen, is acidic. Then, once you've lost two hydrogens, it goes basic, and when you've got no hydrogens, it's basic as well. So the first two are acidic, the second two are basic. All right, and if you're looking for which is the most basic, this is the most basic. This is just basic. This is acidic, and this is more acidic, if that makes sense. Yep, okay. Right, let's move on. So, some of these fancy salts, right, contain a highly charged positive metal cation, okay? So in the table, it was aluminium and iron, okay? So those are the 3+ aluminium and iron ions, okay? And these can form complex ions which have the ion surrounded by water molecules. And then one of those water molecules donates a proton to form a hydroxide ion and a hydronium ion. So let's go through an example. So aluminium, the ion, is surrounded by 6 water molecules. And I'm not going to draw out a water molecule, but I'm just going to draw out a H2O. Each of those is a H2O. And so you would write that out as Al in square brackets with a round bracket here, H2O 6, 3+, and these are square brackets. Okay, so that is the complex ion, all right? Because all these waters are highly attracted to it, and if you wanted to draw out one, you should know which way they go. The oxygen goes in towards the center because it's the negatively part of the molecule, right? And it forms a ligand with the ion, all right? And so that's that particular orientation. All right, so this has the ability, so before it had no hydrogens. And remember, to be an acid, it has to have hydrogens. Okay, so these highly charged positive metal cations are listed as acidic in the table. So now it has these waters around it, has the ability to act as a proton donator. So what will happen is that one of these protons will be donated off, and it will form, well, I'll just add it to some water. It will form the H3O+, so that's this thing here going to there, making H3O+. Yep, right, that makes sense. But then what's left over? It's an aluminium ion with 5 waters around it and 1 OH, because one of those hydrogens fell off, okay? And how would you write that? Well, then now it's a square bracket again, Al bracket H2O. Now, how many waters have I got? 5 now. And I've also got an OH, and it is now only 2+, because the OH is a 1- and the Al is a 3+, so overall that's a 2+ on that complex ion. Okay, so I was supposed to show that with ammonia, so I could, if I just cross this one out and instead form it with ammonia, it will form NH4+, okay? But that's the idea, okay? So the idea is that these things form complex ions. This thing is a complex ion, all right? This is also technically a complex ion as well, all right? And that's how they can act as an acid. All right, that's it. Adios.